to get to atmospheric pressure, we got to get to the atmosphere. And that's really the big thing in this course. So here's what you want to do. So the atmosphere of Earth is extremely thin, right? You've always heard the story. Just think about it. How big is the sky? That's really the question we're asking. So when I ask the question, when I say the question that the atmosphere of the Earth is extremely thin, we're really asking how big is the sky? How many times have you thought about how big the sky is? And here's the way you can do to get a sense of this. What you want to do here is that you want to draw two lines as close as possible. So what you want to do here, so if you were to do this right, you would want to make, so you would draw a circle like this. Now, of course, this is a really small circle. So if you want to get a sense of this, you have to draw the circle where it has a diameter of 1 meter. So it should be 3 feet in diameter. Okay, so now here's what we have. We have the Earth right here. And then what you want to come back, so this should be really 1 meter like this. So typically in a classroom, I would literally measure this out. And it's a huge circle, right? It's a very, 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 very big circle. And then what you need to do here is that you need to come back and you have to get as close as you can to the other line. So what we're talking about here is we're talking about the space between these two lines. So what you do here is that the space between these two lines is the thickness of the atmosphere. Now, what does that even mean here? What that means here is that, say that's the thickness of the atmosphere, it contains 99% of the Earth's atmosphere. So to give you some numbers here so you can get a sense of this, here we go. The radius of the Earth, this is about 4,000 miles. So if I go from the center of the Earth all the way to right there, that's the radius. Now, the thickness of the atmosphere is 18 miles. So you know how far the thickness, do you know how far 18 miles is? I'll tell you how far 18 miles is. If you're in downtown, so just to make sure that we're clear, what do I mean by 18 miles? So the distance from Watsonville, right? So I'm talking downtown Watsonville to downtown Santa Cruz is around 18 miles. Think about that. Every time you drive from downtown Santa Cruz to downtown Watsonville, you have driven the size of the sky. It's shocking how many times people think that the sky is this really, really big thing. It's not. So if I take these two numbers to give you a sense of this, this is what I want to do. I want to take the thickness of the atmosphere divided by the radius of the Earth, and this number is this is 18 over 4,000, and this turns out to be 0.0045, which implies that the thickness of the atmosphere is about 0.5%. It's not even 1% the diameter of the Earth or the radius of the Earth. So you could see here is that this tells us that the atmosphere is what? It's extremely thin. It's extremely thin. The sky is not limitless, right? That's a really surprising feature. I remember when I was young and I saw that and I went like, wow, really? My impression of the sky being huge was a misconception. So then, now that we've talked about the atmosphere, the question that we should answer now is, why do we have an atmosphere? Right? Why do we even have an atmosphere? And the answer to this, it turns out to be two things. So there is two pieces to this. So the first one is, it turns out the sun. So the sun, what it does here, the sun heats up the air and gives the air molecules kinetic energy. And so what happens here is that when you do that, then what you'll find here is that there's a range of values. What you'll find here is that at sea level, okay, I'm going to run out of space, so I'm going to move this down here actually. So there's two pieces to this thing. At sea level, they travel about 500 miles an hour. So the air molecules that are colliding with you right now in your room are traveling a couple hundred miles an hour, which is shocking. But because they have such tiny masses, you don't really feel individual air molecules. The other thing that we find is at the top of the atmosphere, these air molecules are traveling about 1,000 miles an hour. So they're traveling much, much faster. And those are the ones that get up to the top of the atmosphere. And then so that's what the air molecules, so now you're finding here is that the air is actually escaping, trying to escape. So since air molecules have kinetic energy, they are trying to escape Earth. But gravity pulls them down. So the second important piece here is gravity. So gravity stops, it doesn't stop all the air molecules. it stops the air molecules, most of the air molecules from leaving. And so, but there is a loss of air. The Earth is constantly losing air. And then, you might be asking the question, if we're constantly losing air molecules, then why is it that we have, an atmosphere? It turns out that rocks are also gassing air molecules too. So there's a combination of new air always being produced as well as air leaving the atmosphere. And so what you find here is that this is what gravity does. So when you look at gravity, we could imagine that we have mountains. So if I look at this guy here, we have a range of mountains, and we could probably say that this guy here, this is about Mount Whitney. So if you've ever been to Mount Whitney is about the 5-kilometer mark. And then I didn't draw this very good, did I? Then I have to go a little bit higher. And then, of course, we have some of the biggest mountain that people talk about all the time is Mount Everest. And Mount Everest is about 10K. And what you're finding here is that at 5K, 5 kilometers, below this line represents 50% of the air. And so as we start to go up, when you get to the 20-kilometer mark, what you'll find here, maybe I should put this off to the side. Again, I'm running out of space. So let me move this down a little bit. At the 20-kilometer mark, what you'll find here is that this line represents that everything below this is 90% of air. And if you get to the 30-kilometer mark, you'll find that this mark gives you that's 99% of the air. So what they call the top of the atmosphere is actually the 40-kilometer mark. So they're saying that this 40-kilometer mark is the top of the atmosphere. And that represents the ozone layer. So if you've ever heard the ozone layer, that's what they mean by that. And of course, this is sea level right here. So gravity, you could see here, keeps most of the air below 5 kilometers. And then as you go higher, you could see that the air is thinning out.